Today's objective is that you will graph and interpret piecewise functions. Now, a piecewise function is going to be exactly what it sounds like. It is a function that appears to be in pieces. So we've seen square root functions and circle functions and tangent functions and a whole bunch of different function families. But sometimes, actually quite often in the real world, one function doesn't describe something forever. Maybe it starts as a square root function, but then it becomes a constant function, or starts linear and then becomes quadratic. This happens a lot. So this is the beginning of where that's going to go. So you see this graph clearly is several different things. So every time there's like a weird corner, it seems to change the function that it is. But together, it's all one function. So we're going to answer some questions about this to start. Domain, you remember, is the possible x values from the lowest or farthest left to the highest to farthest right. Farthest left, this seems to go to -3, and farthest right, this seems to go to 9. So we write -3 to 9. And since it both seems to touch -3 and touch 9, that means we put the hard bracket on to show that those are included. The range is bottom to top, lowest y value to highest y value. The lowest y value is down here, that's -3. The highest y value is all the way up here, that's +3. So our range, -3 to +3, and same thing as domain, both of those values seem to be included. That's old stuff. Now we get to the more interesting question. How many distinct pieces of this graph are there? Well, in my count, there seems to be 4. We have something right here that appears to be part of a circle. We have something right here that is straight, that means it's linear. We have something right here that is also straight, which means it's linear, but it's also straight and flat, which means it's constant, that special kind of linear. And then we have something that is straight but not flat, which means we have another linear. So we just kind of answered 2 of these questions here. There seem to be 4 distinct pieces of the graph. And then in order, these are a circle, or a piece of a circle, followed by a linear piece, followed by a constant piece, which is a type of linear, and finally the last one is also linear. I wrote that in yellow, you probably can't see it, but that says linear. Here's what you're really going to be doing in a lot of our examples. I gave you the function. This says that this function is equal to 4 different things, and then the lines represent each domain of where those pieces exist. So the first one is a circle written in red here, and you can tell that it's a circle because it's got that parent function, square root of r squared minus x squared, but that doesn't really matter so much. It will always be written left to right. So 1, 2, 3, 4 correspond to 1, 2, 3, 4. What the spaces ask us for is on which domains this exists. So before we do that, just really quickly, if I say something like this, -3 to 9, that was the domain. This is interval notation. Remember, we practiced, you can also do this as inequality notation, which is -3 less than or equal to x less than or equal to 9. These things mean the same thing. And there's no reason why I'm going to ask you to use this one, except that that's what everyone in the world does for piecewise functions. So you're going to want to write it like this because we use it more often, but for piecewise functions, just use inequality notation. It's the same idea. So the circle piece goes from an x value of -3 until an x value of 0. Remember, we're only using x values here. So we say -3 less than or equal to x less than or equal to 0. The next piece is the blue one, that's the linear function, and that starts at x equals 0 and goes to x equals 4. So that's 0 less than or equal to x less than or equal to 4. Notice that where this one stopped at 0, this one picked up right at the same spot. Third, we have the constant function. That only goes from x equals 4 to x equals 6. So 4 is less than or equal to x is less than or equal to 6. And then the last one, actually I'll write this in black instead of yellow, goes from an x value of 6 until an x value of 9. So this is 6 less than or equal to x is less than or equal to 9. All of these, I use the or equal to, but you will see some examples where it's just greater than or less than. Remember, if it comes out to one of these, then that would be not included. So that would be a greater than or less than symbol instead of or equal to. So that is it. Our objective is to graph and interpret piecewise functions, and we are focusing on each of these, which are called restricted domains. So just part of the domain instead of the whole domain.